Welcome to session 8 of our ethical hacking course. My name is Rob Chubbuck from Mission Critical Institute. This session focuses on sniffing concepts. By sniffing, you can monitor all sorts of traffic, either protected or unprotected. Using sniffing, the attacker can gain such information which might be helpful to further attacks and cause trouble for the victim. Furthermore, you will learn about media access control or MAC attacks, DHCP or dynamic host configuration protocol attacks, address resolution protocol or ARP poisoning, MAC spoofing attacks, DNS poisoning. Once you are done with sniffing, you can proceed to launch attacks such as session hijacking, denial of service attacks, man-in-the-middle attacks, to name a few. Remember that sniffers are not hacking tools. They are actually diagnostic tools typically used for observing network, troubleshooting issues, and listening in for any kind of issues within the traffic. Sniffing concepts. Sniffing is the process of scanning and monitoring the captured data packets passing through the network using sniffers. The process of sniffing is performed by using promiscuous mode ports. By enabling the promiscuous mode function on the connected network interface, this allows all traffic to be captured, even when the traffic is not intended for the target. Once the packet is captured, you can easily perform the inspection. There are two types of sniffing. There is active sniffing and passive sniffing. Using sniffing, the attacker can capture packet-like information such as syslog traffic, DNS traffic, web traffic, email, as well as other types of data traffic flowing across the network. By capturing these packets, an attacker can reveal information such as data, username, passwords, and other information from protocols such as HTTP, POP, IMAP, SMTP, NMTP, FTP, Telnet, and RLogin, to name a few. Anyone with the same LAN or connected to the target network can sniff the packets. Let's focus on how sniffers perform their action and what we get using sniffing. In the process of sniffing, an attacker gets connected to the target network in order to sniff the packets, using sniffers, which turns the network interface card, or the NIC, of the attacker system into promiscuous mode. The attacker captures the packets. Promiscuous mode is a mode of the interface in which the NIC responds to every packet it receives. As you can observe in the figure here, the attacker is connected in promiscuous mode, accepting each packet, even those packets which are not intended for them. Once the attacker captures the packets, they can decrypt these packets to extract the information. The fundamental concept behind this technique is if you are connected to a target network with a switch as opposed to a hub, broadcast or multi-traffic is transmitted on all ports. The switch forwards the unicast packet to the specific port where the actual host is connected. The switch maintains its MAC table to validate who is connected to which port. In this case, the attacker alters the switch configuration by using different techniques such as port mirroring or switched port analyzer, or SPAN. All packets passing through a certain port will be copied to a certain port, the port on which the attacker is connected with promiscuous mode. If you are connected to a hub, it will transmit all packets to all ports. Types of sniffing. Passive sniffing is the sniffing type in which there is no need to send additional packets or interfering with the device, such as a hub, to receive packets. As we know, hub broadcasts every packet to its ports, which helps the attacker to monitor all traffic passing through the hub without any effort. Active sniffing is the type of sniffing when the attacker has to send additional packets to the connected device, such as a switch, to start receiving packets. As we know, a unicast packet from the switch is transmitting to a specific port only. The attacker uses certain techniques such as MAC flooding, DHCP attacks, DNS poisoning, switch port stealing, ARP poisoning, and spoofing to monitor traffic passing through the switch. These techniques are defined in detail later in the session. Protocol analyzers, either hardware or software, are used to analyze the captured packets and signals over the transmission channel. Hardware protocol analyzers are physically equipment which can be used to capture without interfering of the network traffic. The major advantage offered by these hardware protocol analyzers are mobility, flexibility, and throughput. Using these hardware analyzers, an attacker can monitor network usage, identify traffic from hacking software, decrypt the packets, extract information, and look at the size of the packets themselves. Span port. You have a user who has complained about network performance. No one else in the building is experiencing the same issue. You want to run a network analyzer on the port like Wireshark to monitor the ingress and egress traffic to the port. To do this, you can configure a span port, a switch port analyzer. Span allows you to capture traffic from one port on a switch to another port on the same switch. Span also makes a copy of all frames destined to the port and copies them to the span destination port. Certain traffic types are not forwarded by span, like BDU-PU, CDP, DTP, VTP, and STP traffic. The number of span sessions can be configured on a switch is model dependent. For example, Cisco 3560 and 3750 switches can only support up to 2 span sessions at once, whereas the Cisco 6500 series switches support up to 16. Span can be configured to capture either inbound, outbound, or in both directions of traffic, and you can configure a span source as either a specific port, a single port in an either channel group, an ether channel group, or a VLAN. Span cannot be configured with a source port of a multi-chassis ether channel. You cannot configure a source of a single port and a VLAN. When configuring multiple sources for a span session, you simply specify multiple source interfaces. One thing that has to be kept in mind when configuring span is if you are using a source port that has a higher bandwidth than the destination port, some of the traffic may be lost or dropped if the link is congested. Simple local span configuration. Consider the following diagram in which router 1 is connected to switch through the switch's fast Ethernet port 01. This port is configured as the source span port. Traffic copied from FEQ1 is to be monitored out FEQ24, where the monitoring workstation is waiting to capture the traffic. Once we have our network analyzer set up and running, the first step is to configure the Fast Ethernet 01 as the source span port. Configure Fast Ethernet 024 as the destination span port. After configuring both interfaces, destination span port LED FEQ24 began flashing in synchronization with that FEQ1's LED. This is expected behavior considering all FEQ1 packets were being copied to FEQ24. Wiretapping is the process of gaining information by tapping the signal from the wire, such as the telephone lines or the internet. Mostly, wiretapping is performed by a third party to monitor the conversation. Wiretapping is basically electrical tap on the telephone line. Legal wiretapping is called legal interception, which is mostly performed by government or security agencies. Wiretapping is classified into 2 types. Active wiretapping. Active wiretapping is monitoring recording of information by wiretapping, and additionally, active wiretapping includes the alteration of communication. And then passive wiretapping. Passive wiretapping is the monitoring and recording of information by wiretapping without any alteration of the communication itself. Lawful interception is the process of wiretapping with legal authorization, which allows law enforcement agencies to wiretap the communication of an individual user selectively. Telecommunication Standardization Organization standards the legal interception gateways for the interceptor of communication by agencies. Planning tool for resource integration, or PRISM. PRISM planning tool for resource and integration stands for synchronization management. PRISM is a tool that was specifically designed to collect information, process, and pass through American servers. The PRISM program was developed by the Special Source Operation SSO Division of the National Security Agency, NSA. PRISM is intended for the identification and monitoring of suspicious communications of targets. Internet traffic routing through the U.S. or data stored in the U.S. servers are wiretapped by the NSA. Here is your mind map for sniffing. MAC attacks. Media access control address is short as MAC address or physical address of the device. The MAC address is a 48-bit unique identification number that is assigned to a network device for communication at the data link layer. The MAC address is comprised of object unique identifier, OUI, 24 bits, and 24 bits of the network interface controller, or the NIC. In case of multiple NICs, the device will have multiple unique MAC addresses. The MAC address table, or content addressable memory, CAM table, is used in Ethernet switches to record the MAC addresses and its associated information, which is used to forward packets. CAM table records a table in which each MAC address information are associated VLAN information, learning type, and associated port parameters. These parameters help at the data link layer to forward packets. To learn the MAC address of a device is a fundamental responsibility of switches. The switch transparently observes incoming frames. They record the source MAC of these frames in their MAC address table. It also records the specific port for the source MAC address. Based on this information, it can make intelligent frame forwarding decisions or switching. Notice that a network machine could be turned off or moved at any point. As a result, the switch must also age MAC addresses and remove them from the table after they have not been seen for some period of time. The switch supports multiple MAC addresses on all ports so that we can connect individual workstations as well as multiple devices through a switch or router as well. MAC flooding. MAC flooding is a technique in which the attacker sends random MAC addresses mapped with random IPs to overflow the storage capacity of the CAM table. As we know, the CAM table has a fixed length. The switch then acts as a hub. It will now broadcast packets on all ports, which helps the attacker to sniff the traffic with ease. For MAC flooding, Unix or Linux utility MACOFF, MACOF, offers MAC flooding. Using MACOFF, random source MAC and IP can be sent on an interface. Switch port stealing. Switch port stealing is also a packet sniffing technique that uses the MAC flooding to sniff the packets. In this technique, the attacker sends a bogus ARP packet with the source MAC address of the target and destination address of its own, as the attacker is impersonating the target. Let's say host A When this is forwarded to the switch will update the CAM table. When host A sends a packet, the switch will have to update it again. This will create the race condition, in which if the attacker sends ARP with host A's MAC address, the switch will send packets to the attacker, assuming host A is connected to this port. Defending against MAC attacks. Port security is used to bind MAC addresses of known devices to physical ports, and violation action is also defined. So if an attacker tries to connect its PC or embedded device to the switch port, then it will shut down or restrict the attacker from even getting or generating an attack. In dynamic port security, you configure the total number of allowed MAC addresses, and the switch will allow for only that number simultaneously, without regard to those MAC addresses are. Configuring port security. Cisco Switch offers port security to prevent MAC attacks. You can configure switch either statically defined MAC addresses only or dynamic MAC learning upon to a certain range, or you can configure port security with a combination of both, as what is shown here. The following configuration on a Cisco switch will allow specific MAC addresses and up to 4 additional MAC addresses. If the switch has learned the static MAC address, then it will continue to function. DHCP attacks. DHCP, or Dynamic Host Configuration Protocol, is the process of allocating the IP address dynamically so that these addresses are assigned automatically, and also that they can be reused when hosts don't need them. Round-trip time is measured of the time of discovery of the DHCP server until obtaining the lease IP address. RTT can be used to determine the performance of DHCP. By using a UDP packet broadcast, DHCP client sends out an initial DHCP discover packet because it initially doesn't have network information to which they are connected. This DHCP packet discovery is replied by the DHCP server with a DHCP offer packet offering the configuration parameters. DHCP client will send DHCP request packets destined for the DHCP server for requesting the configuration parameters. Finally, the DHCP server will send the DHCP acknowledgement packet containing the configuration parameters back. DHCP uses 2 different ports, UDP port 67 and UDP port 68 for the client. DHCP relay agent forwards the DHCP packets from the server to the client and the client to the server. The relay agent helps the communication, like forwarding the requests, and replies between the clients and the servers. The relay agent, when receiving a DHCP message, will generate a new DHCP request to send it out from another interface that includes the default gateway information as well as the relay agent information option, or option 82. When the relay agent gets a reply from the server, it removes the option 82 and forwards it back to the client. The working of the relay agent in DHCP version 6 is the same as IP version 4 relay agent in the DHCP version 4 server. DHCP server receives the request and assigns the IP address, the DNS, the lease time, and other necessary information to the client, whereas the relay server forwards the DHCP messages. The DHCP starvation attack is a denial of service attack on the DHCP server. In DHCP starvation attack, the attacker sends a bogus request for broadcasting to the DHCP server with a spoofed MAC address to lease all IP addresses in the DHCP address pool. Once all IP addresses are allocated, upcoming users will be unable to obtain an IP address or renew the lease. The DHCP starvation attack can be performed using tools such as DHCP starve and Yersinia. A rogue DHCP server attack is performed by deploying the rogue DHCP server in the network along with a starvation attack. When a legitimate DHCP server is in the denial of service attacks, DHCP clients are unable to gain IP addresses from the legitimate DHCP server. Upcoming DHCP discovery, IPv4 or solicit IPv6 packets are replied by bogus DHCP server with the configuration parameters which directs the traffic toward it. Defending against DHCP starvation and rogue server attacks. It's actually very easy for someone to accidentally or maliciously bring a DHCP server down in a corporate environment. DHCP snooping is all about protecting against it. In order to mitigate these attacks, DHCP snooping feature is enabled on network devices to identify only trusted ports from the DHCP traffic, either ingress or egress direction is considered legitimate. Any access port who tries to replay a DHCP request will be ignored because the device will only allow DHCP process from the trusted port as defined by the network team. It is a security feature which provides network security via filtering of untrusted DHCP messages and by building and maintaining DHCP snooping binding database known as the DHCP snooping binding table. The DHCP snooping differentiates between untrusted interfaces that are connected to the end user and the host and trusted interfaces that are connected to the legitimate DHCP server or any other trusted device. Port security. Enabling port security also mitigates the attack by limiting the learning of a maximum number of MAC addresses on a port, configuring violation actions, aging times, etc. ARP poisoning. ARP is a stateless protocol that is used within the broadcast domain to ensure the communication by resolving the IP address to the MAC address mapping. It is in charge of L3 or Layer 3 and Layer 2 address mappings. ARP protocol ensures the binding of the IP address and MAC addresses. By broadcasting ARP requests with IP address, the switch can learn the associated MAC address information from the reply of the specific host. In the event that there is no map or the map is unknown, the source will send broadcast to all nodes. Just the node with the coordinating MAC address for that IP will answer to the demand with a packet that involves the MAC address mapping. The switch will learn the MAC address and its connected port information into its fixed length CAM table. As shown in this figure, the source generates the ARP query by broadcasting the ARP packet. A node having MAC address the query is destined for will reply only to this packet. The frame is flooded out all ports other than just the port on which the frame was received if the CAM table entries are full. This also happens when the destination MAC address in the frame is the broadcast address. The MAC flooding technique is used to turn a switch into a hub in which the switch starts broadcasting each and every packet out across all ports. In this scenario, each user can catch the packet even though those packets are not intended for them. ARP spoofing. In ARP spoofing, the attacker sends a forged ARP packet over the local area network. In the case, the switch will update the attacker's MAC address with the IP address of a legitimate user or server. Once the attacker's MAC address is learned with the IP address of a legitimate user, the switch will start forwarding the packets to the attacker intending that it is the MAC of the user. Using the ARP spoofing attack, the attacker can steal information by extracting from the packet received intended for the user over the LAN. Apart from stealing information, ARP can be used for session hijacking, denial of service, man-in-the-middle attacks, packet sniffing, data interception, connection hijacking, voice over IP tagging, connection resetting, and stealing passwords. Defending ARP poisoning. Dynamic ARP inspection, or DAI, is used with DHCP snooping. IP to MAC bindings can track from a DHCP transaction to protect against ARP poisoning, which is an attacker trying to get your traffic instead of your destination. DHCP snooping is required in order to build the MAC to IP bindings for DAI validation. Configuring DHCP snooping and dynamic ARP inspection on Cisco switches. DAI is used with DHCP snooping. IP to MAC bindings can be tracked back to the DHCP transactions to protect against ARP poisoning. DHCP snooping is required to build those MAC to IP bindings for DAI validation. And here's the configuration on a Cisco switch for this. And here you can see a show IP DHCP snooping on the Cisco switch, which also will give the information of the configuration. Spoofing attacks. MAC spoofing is a technique of manipulation of the MAC address to impersonate the legitimate user or launch an attack, such as a denial of service attack. As we know, the MAC address is built on the network interface controller, which cannot be changed, but some drivers do allow you to change the MAC address. This masking process of the MAC address is known as MAC spoofing. The attacker sniffs the MAC addresses of users that are active on the switch ports and duplicates the MAC address. Duplicating the MAC can intercept the traffic, and the traffic destined to the legitimate user may direct to the attacker. There are several tools which offer MAC spoofing with ease. This includes Technetium MAC Address Changer and SMAC, S-M-A-C. How to defend against MAC spoofing. In order to defend against MAC spoofing, DHCP snooping, dynamic ARP inspection are effective techniques to mitigate MAC spoofing attacks. Additionally, SourceGuard feature is configured on the client-facing switch ports. IP SourceGuard is port-based feature which provides source IP address filtering. SourceGuard feature monitors and prevents the host from impersonating another host by assuming the legitimate host's IP address. In this manner, the malicious host is restricted to use assigned IP addresses. SourceGuard uses dynamic DHCP snooping or static IP source binding to match IP addresses to hosts on untrusted Layer 2 access ports. Initially, all types of inbound traffic from the protected port is blocked except for DHCP traffic. When the client receives an IP address from the DHCP server or the static IP source binding from the administrator, the traffic with the assigned source IP address is permitted from the port. All bogus packets will be denied. In this manner, SourceGuard protects from the attack by claiming a neighbor's host IP address. SourceGuard creates an implicit port address control list. DNS poisoning. Domain name system, or DNS, is used in networks to translate human-readable domain names into IP addresses. When a DNS server receives a request, it doesn't have the entry. It generates a query to another DNS server for the translation and so on. DNS server having the translation will reply to the request to the requesting DNS server, and then the client's query will be resolved. When a DNS server receives a false entry, it updates the database. As we know, to increase performance, DNS servers maintain a cache in which the entry is updated to provide quick resolution of queries. This false entry causes a poisoning in the DNS translation, which continues until the cache expires. DNS poisoning is performed by attackers to direct the traffic towards the servers in computers owned or controlled by the attackers. Intranet DNS spoofing is normally performed over local area networks with a switched network. The attacker, with the help of ARP poisoning techniques, performs an intranet DNS spoofing. The attacker sniffs the packet, extract the ID of the DNS request, and reply with the fake IP translation directing the traffic to the malicious site. The attacker must be quick enough to respond before the legitimate DNS server resolves the query. Internet DNS spoofing is performed by replacing the DNS configuration on the target machine. All DNS queries will be directed to the malicious DNS server controlled by the attacker, directing the traffic to the malicious sites. Usually, Internet DNS spoofing is performed by deploying a Trojan or infecting the target and altering the DNS configuration to direct the queries towards them. Similar to Internet DNS spoofing, proxy server DNS poisoning is performed by replacing the DNS configuration from the web browser of a target. All web queries will be directed to the malicious proxy controlled by the attacker, redirecting the traffic to the malicious sites. As we know, normally Internet users are using DNS provided by the Internet Service Provider, or the ISP. In a corporate network, organizations use their own DNS servers to improve the performance by caching frequently or previously generated queries. DNS cache poisoning is performed by exploiting flaws in the DNS software. The attacker adds or alters the entries in the DNS record cache, which redirect the traffic to the malicious site. When the internal DNS server is unable to validate the DNS response from the authoritative DNS server, it updates the entry locally to entertain the user requests. Here's our DNS poisoning mind map and sniffing tools. Wireshark is one of the most popular, widely used network protocol analyzer tools across the commercial, government, nonprofit, and educational space. It is a free, open-source tool available for Windows, Linux, Mac, BSD, Solaris, and other platforms natively. Wireshark also offers a terminal version called T-Shark. The following are filters of Wireshark to filter various types of output. Equal, either equal sign, or EQ, or not equals, bang equals, or NE, or contains. Various countermeasures. The best practices against sniffing includes the following approaches to protect the network traffic. Use HTTPS instead of HTTP. Use SFTP instead of FTP. Use a switch instead of a hub. Configure port security. Configure DNS snooping. Configure dynamic ARP inspection. Configure source guard. Use sniffing detection tools to detect NIC functioning in a promiscuous mode. Use strong encryption protocols. Sniffing detection techniques. Ping technique is used to detect a sniffer. A ping request is sent to the suspected IP address with a spoofed MAC address. If the NIC is not running in promiscuous mode, it will not respond to the packet. In case, if the suspect is running a sniffer, it responds to the packet. Now, this is an older technique and no longer viable or reliable. Using ARP. Sniffers can be detected with the help of an ARP cache. By sending a non-broadcast ARP packet to the suspect, the MAC address will be cached if the NIC is running in promiscuous mode. The next step is to send a broadcast ping with a spoofed MAC address. If the machine is running in promiscuous mode, it will be able to replay the packet only as it has already learned the actual MAC from the sniffed non-broadcast ARP traffic. Promiscuous detection tools such as Prompt Query UI or Nmap can also be used for detection of network interface cards running in promiscuous mode. These tools are GUI-based and application software.